Hi, everyone. This is the second podcast here. We're going to be talking about Lecture 2, and then we're going to be talking about the math review. So Lecture 2 specifically looked at the essentials of supply and demand. So we first invested some time in looking at what demand meant for us. We know that there was a downward sloping relationship. We created this law of demand. And then we looked at a general functional form between quantity and prices. And so why does this inverse relationship exist? And we emphasize specifically because of the law of diminishing marginal utility, as well as the income and substitution effects. So what do these effects essentially mean for us? And so the income effect for us was looking at how purchasing power will help to decide how many goods and services that we buy. And so this income effect has a little bit to do with the idea of normal versus inferior goods. And so knowing those differences, I think, are important. And then as well as the substitution effect. And we talked about the reinforcement of the substitution effect with the income effect, essentially. So what is market demand? Well, when we look at individual demanders, we notice that market demand is going to be the summation horizontally of each individual demand at a specific price, P. And as a result, we get a market demand. So in our simple example here in slide 8, we looked at the quantity demanded for one person is equal to the second person is equal to the third person. And so we just sum at every price in order to get market demand. Now this example was a little bit more difficult, and we talked about two different demanders. And what made this problem a little bit more difficult was the fact that we had a kink in our demand curve, that over a certain price, which we solved out to be 8, over that price, we only were worried about one demand curve, and that became our market. But once we were under a certain price, and that was 8, we had two demand curves that we need to sum together. So that's just a simple way to understand how demand can be a little bit more complicated. And this is the picture that we saw here. So then what determines demand for us? And I think all these determinants are really important. And when we talk about determinants of demand, we want to know which way demand will shift, to the left or to the right. And again, we want to make sure that we're emphasizing what the difference between a shift and a movement is. And so for us, income, like we discussed earlier, could essentially shift us. So we have this idea of normal versus inferior goods. And we understood that this idea was fairly subjective. But changes in income most certainly will shift our demand curve. Tastes of preferences also are going to shift our demand curve left to right. And so we had, as example in class, recent trends in health. We talked a little bit about quinoa and how quinoa is going to, the demand for quinoa changed. We went through that economics in action kind of article where we discussed in real-world scenarios to determine kind of how preferences and taste changes are moving the demand curve. We also talked a little bit about the idea of prices of related goods, and these are substitutes and complements. And I think these are really important because we want to make this distinction that prices outside of the market of interest can shift demand in the market we're analyzing. So a simple example would be, how does the price of crude oil affect the demand for gasoline? Since we had a price in the outside market, we could certainly see a shift in the market for gasoline, and that'll come up when we talk about supply here. The other effects that determine demand are price expectations. Again, this seems fairly intuitive that if you believe prices to be lower in the future, then demand today will be lower. And then we had the number of consumers in the market. And again, this comes specifically from adding individual demanders. And we can see that the market demand will shift out. And so we created this generalized function for market demand below. And this generalized function is going to give us some really important information. It's going to tell us each of the marginal changes and what they represent. Now again, these partial derivatives, and if you're new to the idea of partial derivatives, what we're doing here is imagining every other variable remains constant except for the variable we want to change. So in this very beginning, partial derivative, we have just prices changing, okay? And so that's going to lead in the change in quantity demanded. And so then we go on to look at how does income change, right? So all of these say ceteris paribus, all else equal. So when we're looking just at the change in income, every other factor of demand remains constant. So we go through a estimated demand equation. And so from your business statistics class, this should look familiar to us. We should be able to understand how to essentially estimate all of these beta parameters. Now, in term for us, if we wanted to find those partial effects, we would have to take the first derivative with respect to each one of those individual variables: prices, income, price of substitutes, complements, so on and so forth. We further described how we can simplify this relationship so that we're only concerned with quantity and price. And if that's true, then all other factors can be grouped into this term here. So we talked about this example, and I think this is a good one in terms of how to interpret and understand a specific demand equation. This problem is something that I would go through at least one more time to make sure that you understand for the quiz. So then we're talking a little bit about the law of supply. So the law of supply for us tells us that there's a direct relationship between the goods and services that we're selling and prices. And so again, if we're looking at the partial derivative with respect to a general supply curve, we see that as prices rise, so does the quantity supplied. So we want to then invoke some more thought into what is developing this supply curve for us. And really, the motivating factor of supply is the idea of marginal cost. And although that's something that you might have remembered from previous classes, this isn't something that we've talked about yet in our class. So for us, profit is defined as pi is equaling total revenue minus total cost. And then we can go further into understanding essentially how total cost is defined. And that's defined generally by the inputs in terms of production. And so we created this structure of total cost. And again, this should look familiar to you if you recall your previous micro classes. Now, why is this important? Because we want to understand what's essentially driving profits here. And any change, any increase in costs to a firm will generally lower profits. And if that's the case, we should see supply shifting to the left, right? There's a reduction in supply as costs rise. And so when we look at the first determinant, we see the prices of productive inputs. Now, this is the example that I expressed. As oil prices rise, what happens in the market for gasoline? Well, if the production inputs increase, we would expect the supply of gasoline to shift to the left or decrease, okay? We also talked a little bit about technology, and this technology, as long as we've indicated that it creates some sort of production efficiency, then we should see supply increasing, shifting from the left to the right. But if it's a technology increase that also affects costs, then those costs should be reflected in a supply curve shifting from the right to the left. We also talked about taxes and subsidies. And again, I would think that this is very similar to understanding how costs are affecting profits. So anytime taxes rise, it's like an additional cost to the firm, and those additional costs to the firm are reflected in a shift left in the supply curve. The last little bit here, we have prices of related goods, and these prices of related goods I think are important, especially for the idea of substitutes. Now I think this is best exemplified through an example, and that is imagine you're a farmer determining what to produce, corn or wheat. Now you look at the price of each good to determine what you're going to create. So if you are a corn farmer, but notice that wheat is priced higher in the market, you're going to reduce the amount of supply of corn and increase the amount of supply of wheat. The other idea here is the price of complements. And again, I stressed in class that although theoretically this makes a lot of sense, practically and empirically, we might not necessarily see this coming to fruition. But the idea is that when there's two goods that are generally produced in conjunction with each other, think of beef and leather, when the price of one of the complements rises, you might see the supply of the other good also rise. The last two that we have in terms of the determinants of market supply are price expectations. Now, as firms believe that prices will rise in the future, they'll hold back output today in order to sell tomorrow. And that makes sense intuitively. I want to maximize my profits, so why not sell at the higher prices? And then lastly, we have the number of firms. And the number of firms, again, when we constructed the market demand, we would construct market supply in a very similar fashion. So we have this, again, more generalized supply function where we could discuss a little bit how each one of these inputs effectively changes the quantity supplied. The next steps that we took once we've introduced demand and supply is to put them together. And so although we don't know formally the ideas of a market, we understand that demanders and suppliers come together, and the mechanism that kind of brings them together is essentially prices. So we say that prices are essentially this rationing mechanism. And so for us, the equilibrium condition requires that the quantity demanded is equal to quantity supplied is equal to Q star, this equilibrium quantity. So in the presence, what we say in excess demand, prices will be bid up until we reach Q star. And then if we have excess supply, prices will be bid down until we reach Q star. Again, this is in the event that there's no government intervention. So with this problem, how do we solve with a quantity demand and quantity supply curve? And it's as simple as setting the equations equal to each other. By doing that, we are invoking the principle that the quantity demanded is equal to the quantity supplied is equal to one quantity, that equilibrium quantity. And so when we do this, we're able to find what P star is, and then we can substitute P star back into either equation in order to find what Q star is. So what happens when we change supply and demand in this market? And so individual changes of demand and supply will lead to unambiguous changes in quantity and prices. So when we have one shift of demand increasing, that'll lead to prices and quantity increasing. When just supply is increasing, that leads to prices decreasing and quantity increasing. Now, when we have simultaneous shifts in supply and demand, when demand and supply are moving together, this may lead to more ambiguous changes at the equilibrium. So we must be careful how to analyze changes in quantity or prices. And this should ring a bell to you. When you talked about this in your microeconomics class, this is a topic that should have been largely emphasized. So then we talked a little bit about what happens in terms of moving outside of this equilibrium. And so the very first thought is, well, what happens when we have a shortage? Right? A shortage is a term that we've all heard before. And so suppose that we have governments stepping in here. And governments are stepping in by creating some sort of price ceiling. Now, this is legally imposed maximum price for a firm in a specific industry. And if that's the case, we're going to find out that the quantity supplied is less than the quantity demanded. And so again, what we have essentially occurring here, if we draw a little graph of supply and demand, we have our price ceiling put in here, price ceiling. And so we have that the quantity demanded is greater than the quantity supplied. Right? So this is legally imposed, and we couldn't get to P star. So for us, anytime that P is less than P star, we're going to have this shortage occurring. And then with a surplus essentially for us is just a little bit of the reverse. We now have a price floor. So we have prices and quantity in this market. We have demand and supply. And now what we have is a price floor. And this price floor prevents us from getting to this equilibrium price, P star. So anytime prices are greater than P star, right, we can think of minimum wage, we might have then a surplus. So these ideas I think are really important moving forward, really understanding the determinants of supply and demand and then applying them in a way that will shift the demand or the supply curve. Now the next bit that we talked about was the idea of some math review. And so on your own, I had you specifically looking at math, and I wanted you to look at how to take derivatives, what are some of the derivative rules, what does it mean for a partial derivative, and then we left to us in class to talk about optimization. And so we talked about the idea of substitution for a technique in terms of optimization. But we described another technique, and that was essentially finding the Lagrangian. So we're going to do a problem with the Lagrangian here to make sure that we're all on board. So the idea, and we talked about steps in class, and we're going to follow those steps to some degree. Here we're faced with a specific function, x1 times x2 plus 2x1, and we're subject to, that's our constraint, 4x1 plus 2x2 is equal to 60. Now what we're going to do in terms of this constrained optimization is form a brand new function, and that is the Lagrangian. So this Lagrangian function that we have here is going to be equal to, we always put our new function first, or our old function first, what we're trying to maximize. So x1 times x2 plus 2x1, and then we're going to add to that lambda times our constraint, and our constraint here was set equal to 0. Right? So that was one of the steps that I told you guys to do. Make sure that your constraint is always set to 0. So when we go back and do this, the very first thing I might determine is, we'll say 60 minus 4x1 minus 2x2 is equal to 0. Now this is important for us because whatever the value, whatever the direction this parameter is, we're going to take that and apply it into our Lagrangian. So since this is 60, since 60 is greater than 0, we put a plus here. If you were to rewrite your Lagrangian in a way that had 4x1 plus 2x2 minus 60 equals 0, since this value, negative 60, is less than 0, we would have had to have changed our Lagrangian to be a negative. Okay? So here we're using the positive. So now the next steps that we take for solving a problem this way is take the partial derivative with respect to each one of our inputs, x1, x2, and lambda. So we'll do x1. And so now we're going to treat any value that isn't an x1 as a constant. So now we have the first term, x1 times x2. Well, the derivative is just x2, plus we have an x1, and the derivative of 2x1 is just 2. And then if we were to distribute lambda, we would see that we would take the derivative of 4 lambda x1 to get 4 lambda. We're going to immediately set that to 0. The next step is take the partial with respect to x2. So again, any value that's not x2, we're going to treat as a constant term. So now we take the derivative of x1, x2 to get x1. This next term, 2x1, drops out because it's a constant for us. The lambda times 60 drops out. The lambda minus 4 lambda x1 drops out because it's a constant. But now we're left with minus 2 lambda, and that's equal to 0. Again, set that equal to 0. And now lastly, we take the derivative with respect to our lambda term, and we will always get back our constraint. So we have 60 minus 4x1 minus 2x2 equal to 0. So we have these three conditions that we now can use to solve for x1, x2, and lambda. So the very first thing that I might accomplish here is eliminating lambda. And I can do that through here and our first equation. So I know that 1/2 x1 is equal to lambda. And so now I can combine these two conditions so that I have x2 plus 2 minus 4 times 1/2 x1 is equal to 0. So then this gives me x2 plus 2 minus 2x1 is equal to 0. Now I can combine this equation with our last equation in order to find what the value of x1 and x2 are. So if we're going to do that, we have our new set of equations that we're going to work with. But first, in order to eliminate the next equation, I want to solve probably this equation again in terms of either x1 or x2. And I'm going to do that. I'm going to say that x2 is equal to 2x1 minus 2. Okay? So now we have this equation, which is just redefined in terms of x2. We can now substitute into our last constraint equation so that we have 60 minus 4x1 minus 2 times 2x1 minus 2 is equal to 0. Okay? So now this is the only equation that we need to work with in order to solve for x1. So bear with me here. But we have 60 minus 4x1 minus 4x1 plus 4 is equal to 0. So now we can solve down so that I have 64 is equal to 8x1. And now I know that we have 8 is equaling x1 star. Now I place the star here to indicate that this is the optimal value of x1 that will maximize or minimize our function. Now the next step is to essentially go back in and solve for x2. So we know that the relationship already, and that is x2 is equal to 2x1 minus 2. So x2 is equal to 2x1 minus 2. And our optimal value for x1 is 8, so we'll plug it in to get x2 star is equal to 2 times 8 minus 2. So we get x2 star is equal to 14. And then lastly, we want to solve for our lambda term. And we know the relationship there. We know that lambda is equal to 1/2 x1. So we're going to take lambda is equal to 1/2 x1. We're going to plug in x star, x1 star to get 8. So that lambda star is equal to 4. And that's it. That's how we would solve an optimization problem this way. And I would suggest that you would be able to use this. I would also encourage you to know how to take the first derivative of a function in a variety of ways. And that means, how could I use the product rule? How could I use specifically the quotient rule? How can I manipulate the equations so that I can use the easiest method for me? Okay? I think the chain rule is going to be very important as well. And so with these topics, I think that would cover most of Lecture 2, what we're going to cover for the quiz, and then what we are essentially going to be working on going forward.